Hi everyone, welcome to this lecture. So in this lecture, we will learn about the Naïve Bayes classification or Naïve Bayes classifier. So keep in mind that this is also the probabilistic classifier after the logistic regression classifier. But here we will apply the probability using Bayes theorem. That is, we will use conditional probability in order to perform classification. Suppose we have two classes. We have a data set which is divided into two classes. We have a class A which is shown with blue color, and we have a class B which is shown in green color. So we have the data set which is spread in two classes as shown here. Now a new data point of feature X comes in our data set. Here is the new data point, and the feature of this data point is X. Basically, this is the feature matrix of this data point X. Now our task is to identify that to which class this new data point belongs to, and we have to use Naïve Bayes classification for that. So this is our task. Given a new point of feature X, find the class for new data point using Naïve Bayes classification or using Naïve Bayes classifier. So this is our decision rule. So basically we have to find two conditional probabilities here. Why two conditional probabilities? Because we have two classes. So this is, we can read this, the probability of class A given X and the probability of class B given X. So we can also explain in that way that given a data point of feature X, what is the probability that it belongs to class A? Similarly, we can also read it as given a data point of feature X, what is the probability that it belongs to class B? So we have to find these two conditional probability, and based on the value of the conditional probability, we will decide in favor of a class. So if that will be greater than that, that is the probability belongs to class A will be high, then the new data point will be belong to class A. Otherwise, we will decide in the favor of class B. So this is a decision rule which we have set. Now we have to perform the calculation of these two conditional probability terms. And for the conditional probability, we know that we have a Bayes theorem of or Bayes rule. So let's refresh our Bayes theorem. So this is the equation of Bayes theorem, which we have already derived in this section. Now we have to remember the name of all these important terms. So PA is the prior probability of event A. If A is the event and B is also the event, in that case, PA is the prior probability of event A. PAB is the conditional probability of event A, and here it is conditioned on the event B. That is it also the posterior probability of event A? That is, given the event B has occurred, what is the posterior probability of event A? This PB is the evidence, or it is the probability of event B. And similarly, here is another important term, PB given A. It is called the likelihood or class conditional probability. So we have refreshed our Bayes theorem. Now it's time to apply in order to perform the classification. So this is the steps to achieve our task. We have to calculate this probability, that is, given the data point with feature X, what is the probability that it belongs to class A, and given the data point with feature X, what is the probability that it belongs to class B. So we have to compare these two probabilities. So we will use Bayes theorem. Now apply Bayes theorem for this value as well and for this value. Okay, now this is P class A given X, or if you compare it with the previous equation where it is probability of A given B, so in that case we have to find the class conditional probability, the probability of class A, this is the prior probability, and the probability of X. And similarly, this is the probability of the evidence that we have a data point. Similarly, for class B, using Bayes theorem, we have this value, that is the probability of X given class B, the prior probability of class B, and the evidence of X. So this is the complete equation for this term, and this is the complete equation for this term according to Bayes theorem. Now we can cancel both this term because this is the common term in both of the terms or both of the expressions. Now we are left with this term, that is the class conditional probability and the prior probability here. And similarly, we are left with the class conditional probability, or we can call it a likelihood as well, and the prior probability of class B. Now, in order to perform this task, basically now we have to find the 4 probability terms: the likelihood for class A and the prior probability of class A, similarly the likelihood of class B, and similarly the prior probability of class B. So how we will proceed? So basically, we can see here we have a class A and class B. So if we count the number of samples in class A, we have only 12 samples. We can easily count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Similarly, if we want to count the number of samples or the data sample in class B, we have 16. So what is the prior probability of class A? So number of samples in class A and total samples in data. So in class A, we have 12 samples. And if I add all those samples, I get 28, that is 12 plus 16. So this is the prior probability of class A. Similarly, the prior probability of class B will be number of samples in class B divided by the total samples in data. So in class B, we have 16 samples and we have 28 samples in total in our data set. So here we have calculated the prior probability of classes A and B very easily. Now it's time to find the class conditional probability for class A. So this is the likelihood or the class conditional probability of class A. So how to find this? So in order to find this, we will create a neighborhood about our test point or a new data point. So this is the size of the neighborhood. Now, after drawing a neighborhood or after sketching a neighborhood around our new test point or our new point, we will be able to find the class conditional probability. So the equation for the class conditional probability is here: number of similar observations with class A, total samples in class A. So when we draw a neighborhood, we can see that in that neighborhood, there are 3 samples of class A. So we will write 3 here, that is number of similar observations with class A, and total samples in class A. So we know that the total sample in class A is 12. So in that way, we have calculated the class conditional probability for class A. Similar way, we will find the class conditional probability for class B, and the equation or the formula is same, that is the number of similar observations with class B divided by the total samples in class B. So in that neighborhood, we have only 1 samples or 1 similar observations with class B, and we have total 16 samples in class B. Therefore, the class conditional probability for class B will be 1 by 16. So in this way, we have calculated the prior probabilities and the class conditional probabilities for both classes. Now it's time to calculate the conditional probability, that is, given a data point of feature X, what is the probability that it belongs to class A? So this will be equals to the class conditional probability of class A into the prior probability of class A. So we have already calculated both these values. Now we can multiply both these values, and when we will solve, we will get 3 by 28. This 12 will be cancelled out with this 12, and we are left with 3 by 28. Similarly, we have already calculated the class conditional probability of class B and the prior probability of class B. So we can put these values here in the equation. So that value was 1 by 16, and the prior probability of class B was 16 by 28. So this 16 will be cancelled out, and we are left with 1 by 28. So we can see that the probability that a given data point belongs to class A is higher than the probability that the given data sample belongs to class B. That is, this is our final decision. Since this probability is higher than this probability, therefore the new data point belongs to class A. So in this lecture, we learn how to perform Naïve Bayes classification. We also see that Naïve Bayes classifier is also the probabilistic classifier. Here we use the conditional probabilities or Bayes theorem in order to perform the classification. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.